The last video published on this channel is about the data injection pattern on Godot. Here, I will show you how to make lists, instantiate lists by using this data injection pattern, and how to have a kind of dynamic display of item or static based on what you need. Here again, I'm taking the example of this game we're making. This here is a horizontal list where we are displaying items horizontally. The program doesn't know initially what items will be displayed. It depends on whatever we are mining at the moment. Another example of this is the inventory. This inventory here is displaying a list of items which is updated when we create a SWORD or when we do remove a SWORD. This is the kind of thing that the list pattern will be handling. So let's get back to the scene we have created in the last video. So if you want to see how we created this thing, you kind of need to go watch the data injection pattern on this YouTube channel. And here what we will do is remove all these items which I have created in the scene tree to see how we can make the code create those for me, so that when we add items, either because we are populating the database or because the game is creating an item in your inventory, all that kind of things, how you can list those things, add things to the list, and remove things to the list when it is necessary. Here what we will be doing is just remove all the items we have created here. Alright, so we just have an empty box container here, and we will create a script for this class, this scene. As a quick reminder, what we want to display in our list is this database of item, which is hard-coded in the item resource file. So what we will do is read this dictionary here, and we will create one item for each value. Alright, so the first thing we want to do here is to prepare the ready function, because this is where we will instantiate the methods. But first, let's see how to instantiate one single item in the list. We have a component right there, and we want to instantiate it in our main view, and we want to add data to it. So in order to instantiate an item, we need a specific scene to load, and we need an item resource data to inject in this item. So here I'll just say that I will use an item resource which will be injected in the instantiated component. As for the scene, there are different places you can put the scene. Here, for simplicity, we will just put here in the properties of the class. So we're going to have the scene, which we will instantiate as a packed scene, and we will just load the components which was created not even in the previous episode, but as a preparation of this episode. So here we copy the path to the resource, and there we go. So the scene being ready, we can create a variable item node, which is going to be a UI item or a node item if you wish. And this is just the instantiation of the scene, right? We take the scene, we instantiate it, and we have a node. At the moment, this node is an orphan node. It's not in a tree. So we'll have to say to Godot, where do we want this node to be attached to in the scene tree. In our situation here, we want this to be attached to the VBox container. I will rename this item container, and I will create a quick path to this. So on ready, I'll create a path to item container, which is going to be a VBox container. And I will fetch this node with a unique name. So I'm using a unique name because it's, in my opinion, safer, so that you can improve the scene, add margins, move things around, and yeah, you will keep the path to the nodes, and that's important. So now that we have an access to the container, we can say that we want to use item container node and call on its add child method to say I want to add a node in the tree here, and this node will be item node. All right, so the item node is in the tree now as a child of the item container. In fact, we could potentially test this to see how this is going so far. By running the scene, we do have an item which is instantiated as a child, and as you can see, we have an item in it, which is the default value set for the item key we have used in the previous video. Now let's see the situation where we want to choose what item we want to display here. So first, I'm going to initialize the database again, because since we're working on the local thing, we have to do that. Typically, that's the game start thing that is handling this database initialization, but here, well, this script is the game, so we had to add this here. Anyway, we want to send an item.dictionary and the value, let's see, maybe the first one we have, which is not dead cat. Okay, we're gonna send this value, and now we need the component to receive this with the inject data method. So if we check a little bit the script, we do see that we have this default value, and really I think I will get rid of that. So I'm gonna remove the export here and the base inject data, as well as the database initialization. It's not necessary anymore. And that's it. I'm doing this for one reason, because right there we don't really want this component to be having a behavior by default. We want this component to work only when it is receiving data, and it's not supposed to not receive data. We can now go back to the view script and say that we want to edit the item node to inject data in it, which is going to be item. So you can do this at different time before adding to the tree, after adding to the tree. It depends on what kind of behaviors your script has on ready or enter tree. But usually what I like to do is to have this kind of things done before you add it to the tree. That's just my way of doing it. The thing is that now, if we do run this, we can see that we have a not dead cat in this item. So this is how we instantiate one item. But the situation is we have a list of items to display here. We have a database to display. So we're going to create another method which is going to run through the database and which will create one item for each database item. So here I will create an instantiate items. So it's a little bit tricky here because the only difference is one single S, but that's the way I like to do it. If you want names which are a little bit clearer and easier to differentiate, please do that. Here, what we'll do is just run through the dictionary. So we will loop in a for loop for every key of the dictionary. So the key is an item enum, and the dictionary's key are item dictionary.keys. For every key, what we will do is instantiate one item, and the item that we will display is item dictionary key. So from there, we just remove this line we have created before, and we instantiate the items with an S, and there we go. We have the entire list of our database, which is showing right now. So this is the quickest way to display this, and here we're doing it with the dictionary. You can do this for arrays as well, it works very well. And the thing is that, for example, the very common thing that I do is to work with arrays for inventories, and to add and remove items. So here it's going to be a little bit special because we have a dictionary, so it works a little bit differently. But I'm going to create an array to show you how this works when you have an array and how you can work with an inventory. All right, so here I just created an array variable and I added all the items to the array as well as the dictionary. So now what I'm going to do is remove this line and change it to work with an array. So for every item in the array items.array, we're going to do the exact same thing. So we're going to instantiate one item with the item from the array. So if we run the application again, same result, exactly the same, because we are again just running through the list or the array and display things. Now let's see the situation where you want to add an item to an already existing list here. Usually what I do is I create a signal which is on item added, which is catching the information of the item being added somewhere else in the game, and we just wait for it to happen and we react to this action. And when this happens, we instantiate the item which we just received. In order to simulate this, I will start with an empty array and then I will be adding 2 items after a few seconds. Here I have a few functions imitating a situation where we would have 1 item in an inventory. Then after some time is passed, we have other items joining in. As you can see, the items are popping one by one. So now the question of removing items is a little bit trickier. So you have different ways to do that. You can just run through the children's of your item container, or you can create a kind of reference list where you are keeping track of the items in there to see and know very quickly what node to remove when an item is removed. So first let's see how we want to remove an item based with the getChildren method. So on item remove, we're going to say what item we want to remove. We want to use the children of the item container and see if the item we have where we want to remove is in there or not. So we're going to run for every item node, basically, which is a UI item in, and we will get those nodes in the children of item container. So we get item container and we use get children on it. So here we will pass every node one by one. And what we will do is check if the item we have here, so if the item is equal to the item node dot item inside of it. So it's underscore item, if I remember correctly. Let's actually see that. We have the underscore item and we don't have get item. So technically, since this is private, we could have a get item method in there, which returns an item like this. It's a little bit cleaner, let's be honest. So if the item is equal to the item node dot get item, then we do want item node to be freed. Right, so let's see how we can do this by, after 1.5 seconds, emitting a signal sort of on item removed, and we're going to remove item array. Let's remove the 1. Begin by adding the 2 items, and then we do remove 1 item in the middle. So this is a simple way to look for items in the list and remove them, but sometimes you might think that running through each children is not really your cup of tea and you prefer to do something which is not looping, which could be interesting when you have a big list, or I don't know. I mean, that's optimization questions and I didn't really explore those yet. But if you don't want to be looping with a for loop, what you can do is keep a list or a dictionary of the relation between the items you have created and the nodes you have created. So what this looks like is by having a node dictionary, basically. So this is a dictionary where the key is going to be the item and the value is going to be the node. So every time you instantiate an item like this, you will have your node dictionary. You will use the item as the key, and you will create an entry which is going to be the item node. When you want to remove an item from your dictionary, you just use the key in this dictionary to get the node. So here, you can make a check that if the node dictionary has the key item, if this key exists, then you will fetch the node dictionary at the key item, and you will queue free this node, because right there, this, I'm just gonna put it like this so that it makes sense, but it is a UI item, right? So because it is a UI item, you can queue free. So the result should be exactly the same. We add 2 items and we remove 1 item. And that's pretty much it. We have covered the basics of the list pattern in Godot and how you can handle lists by using signals and stuff. So here I've not used signals because I actually don't have any inventory manager or anything, and I'm not using buttons for this kind of things, but this is the core structure that you will be using and expanding to then create items and stuff. I hope that was useful and that you enjoyed this video. I will see you in another content. You can find me live on YouTube here and there, or you can join the Discord if you have questions you want us to answer. And yeah, that's a very cool community. So I don't know how to close this now.